Hello and welcome to a video on intersecting functions using a graphical relationship. Take a look at my two functions here. I've defined a red function and a blue function. I'm going to call my red function f of x. I'm going to call my blue function g of x. It really does not matter. They could be interchanged, but right now we'll say red is f and blue is g. And when you look at my two functions, I've identified where they intersect, that they intersect at point A, at point B, and at point C. When I followed my blue function around, I came to the point A. Following blue's definition, I also came to B, and following the blue definition, I came to C. Likewise, if I followed the red definition, I got to A and B and C. What this tells me is that when I plug negative 1.74 for point A into either the blue equation or the red equation, either for f of x or for g of x, if I plug this negative 1.74 in for x in either of those, I'm going to get 1.74 out. Likewise, if I plug in negative 0.64 into f of x, the red function, I'm going to get 0.64 out. And if I plug negative 0.64 into the g of x, the blue function, I would also get positive 0.64 out. And likewise for c, if I plug in 0.89 and do the math, on the red function, I'd get negative 0.89. And on the blue function, if I put in positive 0.89, I would get negative 0.89 out. And since they are the same at each of those points, their value of their y-coordinates would be 0 because they both equal the same number, and any number minus itself is going to equal 0. Let's look at it from the standpoint of comparing what happens on either side of the intersection point. Here's my intersection point at A. When I look at the left side of A and I look at my red function, which is my f function, and I look at a point on the line, I've called it point P, and I want to look at a point on the blue function that has the same x coordinate as the point P does on the red function. So you'll notice that my P point is negative 2, 2, and my Q point is negative 2, 0. P was obtained by following the f function's definition to find the value. When I plugged in negative 2, I got a value of 2. And the Q point came from plugging negative 2 into the blue function, and it gave me 0 for its y-coordinate. When I look at the function at negative 2 for f, so my red function evaluated at negative 2 is 2, and the value of my g function at negative 2 is 0. When I do 2 minus 0, I get a number that is positive. It's greater than 0, so it is positive. Now, and that was on the left side of my point of intersection. Now I'm going to look at the right side of my point of intersection. When I look over here, I look at my value of j, which is on my red function, which is my f function. When I plugged negative 1.5 into my f function, I got positive 1.5 to come out of my f function and my red function. And when I plugged the same x-coordinate in for negative 1.5 into the blue function, I got a value of 2.5 to come out of the blue function, which is my g. When I do my f of x2, my f of negative 1.5, I get 1.5. When I do my g of negative 1.5, I get positive 2.5. When I subtract 1.5 minus 2.5, I get a negative 1, which is less than 0. And so here when I subtracted, I got a positive. Here when I subtracted, I got a negative, and that tells me that there must be a 0 in between a positive and a negative number. So there is an x between my x1, which I called negative 2, and my x2, which I called negative 1.5, where the function, the difference in the functions is 0, so I have an intersection point. If I go back to the previous slide, we notice that that intersection point happens when x is negative 1.74. So here you can see that negative 1.74 is between my x-coordinate of negative 2 and my x-coordinate of negative 1.5. If I were to continue to do this and looked on either side of B, what you would see happen is that I would have these 2 points would give me a negative difference, but these 2 points, if I did 2 over here, I would end up having a positive difference because this one would be above that one. And that kind of helps you understand how it doesn't matter if I go from positive to negative or negative to positive, I'm still going to get an intersection point between the two differences because changing sign requires me to go through 0.